Hello, my name is Bhavik Kalpesh and I am currently pursuing B.Tech in ICT at Marwadi University. We have a task in which we are going to simulate a sample and hold circuit. This task was given to me by Professor Chandrasinh Dhiruba Parmar, who is the head of Information and Communication Technology Department at Marwadi University. Now, in this circuit, our main component is the op-amp IC741. This is an operational amplifier. Now, here's the basic information about the IC741. An operational amplifier, as you can see, is an integrated circuit primarily designed for performing analog computations. These are the some of the characteristics of the IC741. This is the circuit diagram, and we are going to design the circuit and simulate it in a software which is known as multi-sim. Now, a sample and hold circuit is an analog device which samples and holds the voltage for a small specific time. Now, as you can see in the diagram, this is an analog signal and the red dots with the points are indicating the sampling being done. Now, when sampling is done, we have some small points such as this one, this one, this one, and so on. Now, this is how a sample and hold circuit behaves. It actually stays on for a time when we have the voltage to that point, and then it holds the voltage until it gets the other sampling point. Now it holds the voltage until it gets to the other sampling point. So it actually holds the voltage until the next value is given. So here's the application which is known as multi-sim, and we are going to simulate our circuit in this application. Now, as you can see, I have pre-designed the circuit because it is a little bit complex and we do not want to waste our time in designing it. Rather, we will understand and see how the whole circuit behaves. Now, this is the transistor. This is the op-amp IC741. This is the oscilloscope, and this is the function generator where we will generate a wave. As you can see, we are going to give clock voltage. That means this is actually the rate of sampling, being the amount of samples which we are going to take in our circuit. Now, suppose our signal has a frequency of 100 Hz and we have kept set 1 kHz in this clock voltage. That means 1000 Hz upon 100 is 10, which is that there will be 10 samples being taken in a single cycle. To show you that, let me just demonstrate you by simulating the circuit. As you can see, one complete cycle has 10 samples being taken. Suppose we start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is what it actually means. It has 10 samples in one complete cycle. Now, as you can see, the signal actually won't be as perfect as the analog signal received, because these points will be connected straight. So there may be a chance of having a small loss of the data. Now, let me show you by varying our duty cycle, which is 5%, to 30 or say 25%. Now, as you can see, you've got some slant lines being seen over in this portion, this portion, this portion. This indicates that it is following the signal, which is that when you connect this dot, this line, you will get more accurate data or signal compared to the one we performed earlier. Now, let me take the value of duty cycle to approximately 80%. As you can see, when I took the value to 80%, the signal sampling being done and the following the signal is so much accurate compared to our previous results, and when this dots or say points are connected, you will get more accurate result compared to the previous signal samplings. Now, as I said previously, the frequency over here gives you the amount of samples you want to have compared to the our signal with its frequency. Now suppose I set the sampling to 10% so that it is easily visible and the frequency to 500 Hz. Let us see what will happen. As you can see, this is our complete wave, and here we have 1, 2, 3, 4, and 5 samples being taken. 1, 2, 3, 4, and 5. So I showed you how we can have more number of samples in a circuit. Now suppose I take the value of frequency over here as 2 kHz. That is 2000 upon 100, having 20 samples in a single cycle. So as you can see, the number of samples being taken in a single cycle have increased. They are, as you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20, which is 20 samples being taken in a single cycle. Now, you can have an accurate signal in two ways. You either take more number of samples in a single cycle, or you increase the duty cycle of the on and off time. Now, duty cycle is the on and off time of the clock voltage. Now, because when sampling is done, the points being taken in a sample are not exactly a straight line pointing to the signal. They have a small curve type structure. Now, that means we are supposed to have a small on time or say off time. So, to get a more accurate result, if you increase the duty cycle of the clock voltage, you will have your sample signal following the original signal and then giving you an accurate or say a similar signal in the output side when you connect the sampling points. So if you want an accurate signal, you are either going to increase the clock voltage duty cycle, or you are going to increase the number of samples being taken in a single cycle. These are the links from which I have taken my reference. Thank you for watching this video.